Hello and welcome to another video in my PyTorch and neural network series. Today I'll be showing you guys how to build your first neuron. Before we head over to coding, I want to explain to you guys the mathematical operation that we will be implementing in this video. The operation is called the dot product and it is pretty simple. It's a pretty simple operation. To perform this operation, we just need to multiply the elements of each tensor together and add them all up. Just show you this slide over here so you can see we're multiplying them, so we multiply x0 and w0 over here, x1 and w1, and then we just add them all together, and that's what we get the output of a dot product. The notation is pretty simple as well. We just have to put a dot over here in the middle of the matrix or the tensor. So yeah, with that out of the way, we can just move on to coding now. Cool. So yeah, I've come over to Colab and I've imported Torch. So I'm just gonna make a tensor for the x and w like in the previous slide. So let's just make this torch.tensor. We're gonna want to make our own tensors. Then once we've done that, we'll just go. Gonna make this count up to 4. Then I'll just copy paste this. Do the same thing. W, and then after that, and just print W as well. Cool. So after we have both these vectors, we said that we wanted to multiply them. So let's just multiply them quick so we can actually just go x times w, and then we'll print out y. We expect it to be the squares of these numbers, so just adding it while multiplying all of them together. So yeah, get what we wanted. So 2 times 2 is 4, 3 times 3 is 9, and 4 times 4 is 16. So after that, we just need one more step, which is adding them all up together. And to do that, we can just do, we can sum them. So y is equal y dot sum, and then we'll just print y here. And that's basically how you form your first neuron. Let's just clean up this code quick. So let's put all this initializations into one block, and then we'll do the calculations in the other, like this. We can even do kind of this on one line, so dot sum. And we can just delete this, print y, and delete all this. Then we will have our dot product, and it's equal to 30. Cool. So yeah, that's how you make the dot product, but I think this isn't really that useful, like to kind of scale it up and apply it to many neurons. We're actually gonna have to change this into matrix multiplication. So I'm just gonna show you guys how that's gonna change the operation. It doesn't change much. We're just flipping the w while we're rotating the w tensor, and then that allows us to kind of like stack the w so we can have multiple neurons. Okay, cool. So we implemented the dot product, but I told you guys that we actually want to have kind of a different operation that allows us to stack it. That is where matrix multiplication comes into play. So what we're gonna do is we're just gonna rotate this w so that it's kind of like a column instead of a row. So let me just show you guys. So you can see we rotated it and it gives the same operation, the same output, but this will basically allow us to have multiple neurons in one layer. I'll show you guys how to do that in the next video, but it's pretty simple. We just have to change the dimensions of this. So for matrix multiplication, we just times each row of the first tensor by the columns of the second. So in this case, we only have one row and one column. That would only give us one output, but if we had say 2 columns here, we get 2 outputs, and that's how we'd get like 2 neurons. But anyway, let's just code this so it makes more sense to you guys. Okay, so we're back to Colab, and we want to actually do a matrix multiplication. So we can see here we actually just have two one-dimensional tensors. For matrix multiplication, we need them to be two-dimensional because matrices are 2 dimensions. So to do that, we can just add a dot view. Basically, what this is going to do is we're going to view this tensor, this 1, 2, 3, 4, the single dimensional tensor. We can just give as many like dimensions as we want. We want to view it as like kind of a 3-dimensional like that, but we actually just want 1-dimensional. So we wanted one row. So the first digit indicates how many rows, the second digit indicates how many columns. So we want one row and 4 columns. And then for this, we just want the opposite, which is 4 rows and 1 column. So after we have that, we can let's just print X and Y for you guys, W sorry, for you guys. Cool. Okay, let me just print them separately. X, print W, then you guys can see better. So you see we have the row vector, and now we have a column one as well. So we can multiply them, and I told you guys previously that you can actually just use the at symbol for matrix multiplication. You can also just use torch dot matmul, but we'll use the at symbol. So x at w. It's also important to note that when you operate on these, they have to be in the same like order. So like the x has to come first, and then the w, and then the dimensions will line up, and they'll allow us to matrix multiply if we actually. So let's just run this. We see we get a tensor, and this is still kind of like a matricey that we get. You see it has 2 square brackets on the left and the right. So it's basically just a 1-by-1 matricey. But yeah, if we actually do it the opposite way, you'll see we'll get an error now. Sorry, not. This should be w at x. And we actually don't get an error here, but you can see it's not the output that we wanted. This is probably worse than actually getting an error. So basically what's happening is that PyTorch is actually broadcasting. I'll get into that a little into depth later. So what's happening is it's duplicating x so that it's 4x4, so it just like keeps uh, duplicating the column, the row of x like 4 times, and then I'll duplicate the column of w 4 times, and that's why we'll get a 4x4 output. But yeah, I'll get into broadcasting but later. Just know that this has the order is important over here on this operation. This is a lot better than doing the dot product like I showed you previously. This will allow us to scale up with more neurons and actually more inputs more easily. But I'll show you guys how to do that in the next video where we actually build our first layer.